بسم الله الرحمن الرحيم والحمد لله والصلاة والسلام على رسوله الأمين سيدنا محمد وعلى آله وصحبه أجمعين. This is another lecture in Manufacturing Systems 1 for the 5th year students in Production Engineering and the Department of Mechanical Engineering at the Salama College of Science and Technology. Actually, in this lecture, I'm not going to talk about automation in details because you have studied a lot of bits and pieces of automation in many other subjects. You have studied automation in assembly technology, you have studied automation in pneumatics and hydraulic systems, and so on. So you have got an idea about the components of automatic systems. In this lecture, actually, I'm going to talk generally about what we mean by automation in manufacturing. Let us have a start. Automation definition. Automation can be defined as technology concerned with the application of electronic, mechanical, and computer-based systems to operate and control production. In other words, it is a kind of technology. It's no science. Definitely, it's no science. And it is application of electronics and mechanics and computers. And all those systems are combined together, of course, to operate and control the production. To perform a task without a human intervention to improve productivity and quality. This is another definition for automation. It is to perform a task or a process or anything without a human intervention. That means the machine do it by itself. To improve the productivity, of course, this should be improve the productivity. If it is lower, the productivity is not acceptable, of course. Example of that is CNC machines, automated guided vehicles, and robotics. Many components nowadays are used in automation, as those are components used in automation or automatic automation of production or manufacturing, right? Why we use automation? There are many reasons of why we use automation. Those are some of them. To increase labor productivity. In other words, we use automation besides the workers so as to improve the productivity of workers. To reduce labor cost, of course, if I eliminate labors or workers, I'm going to reduce the cost of workers and machines will never be paid salaries. To mitigate the effect of labor shortage. In other words, some processes or some tasks, laborers find difficulties on doing them, or some of them are hazardous tasks. So this will be eliminated by using automation. To reduce or eliminate routine manual and clerical tasks. Of course, if it is as a process, a routine process, the labor will get bored very soon. So, if a machine do it, machine can do it millions of times without getting bored or without any kind of getting tired or something like that. To improve workers' safety, definitely, I talked about that earlier, but also if a task is hazardous task, of course, it's safe to have automation or to have automatic machine to do it. To improve product quality, of course, machines do the process exactly the same way as many times as it repeated. So the quality definitely will be improved. To reduce manufacturing lead time. Machines are faster than people. We design machines to be faster than people. So the lead time definitely is going to be reduced. To accomplish process that cannot be done manually. Yes, here this point is very important because some processes cannot be done manually because of the fatigue of the process makes the worker tired, sometimes difficult, sometimes need a special way of doing it, so the automatic machine can do it. And there are many examples of this. Say, for making printed circuit boards, easy to use machines because the concentration of the labor of the worker will be diminished in no time, but the machine can do the job many times without any kind of tiredness or fatigue. Automation principles and strategies. Automation is not always the right answer for a given production situation. Asserted caution and respect must be observed in applying automation technology. This is very important, by the way. Automation is not the answer always. It is not the right answer. Sometimes it is the wrong answer even. So when we want to do automation, we have to think about whether is it really acceptable, economically acceptable. Sometimes some process cannot be automated, or the machine itself is very expensive, or the worker can do it better. So not always it is the right answer. Not this only. If the production is just very few numbers of products, I can't go to automation. Say in car industry, all cars now made by automated parts or equipments. But if I want to make only two or three type, three kind of a car, definitely I'm going to do it manually. Three approaches for dealing with automation project. Now, after we know that we can't use automation for any project, how we can execute an automation project? Really, there are three ways or three approaches. I'm going to talk about them. The first approach is what's so-called USA, understand, simplify, and apply principles. I'm going to talk about it in details. Then the 10 strategies for automation and production system, and at last automation migration strategy. We are going to talk about the three of them now. Let us start by USA, understand, simplify, and apply principle. And if I want to automate any process, I try to understand the existing process, how the process being performed, manually or any way we perform it now. Then we simplify this process. We combine two or three tasks together. We try to simplify the way of doing it, and at last we automate the process. And this is what we call U from understand, S from simplify, A from automate. And this is actually a way of doing automation, or a way of strategies applying one of the strategies of or principles of automation. I'm not going to go on details on that because, as you know, we are not teaching automation, we are teaching systems. And I just want you to know about automation as a part of systems, right? USA approach is applicable to nearly any automation project. Of course, any automation project you can Simple linearly. You can do that 3 steps on it. Understand the existing process, simplify the process, then automate the process. Let us go to the 10 strategies for automation and production system. Automation seems a visible solution to improving productivity, quality, or other measure of performance. Then the following 10 strategies for this improvement discussed. In other words, if I found automation is the right process for my production or for my manufacturing work, then apply those 10 strategies. I'm going to discuss those strategies in details now. Specialization of operation. As I said here, the first strategy involves the use of special purpose equipment designed to perform one operation with the greatest possible efficiency. This analogous to the concept of labor specialization, which is employed to improve labor productivity. In other words, I'm going to use special tools and special purpose equipment. And there are many examples of that. It is not the right time to talk about those examples, but there are many examples of that. Say for us, a screwdriver, and if you got a helix around its stem, then if you push it, it's going to rotate instead of rotating it. And of course, the automatic machine can just push the screwdriver down and do the bolting or unbolting of bolts. This is a specialization, or make a special equipment for each process or operation. Combined operations, this is the other one. Production occurs as sequence of operations. Complex paths may require dozens or even hundreds of processing steps. The strategy of combined operations involves reducing the number of distinct production machines or workstations. In other words, if you divide any operation to a very large number of tasks, you find you need a very big machine. But if you combine operations together, say picking and placing in the same operation, and picking, placing, and securing of a component in assembly line as one operation, definitely you are going to reduce the size of machine and hence the economics of the machine, right? Simultaneous operation. A logical extension of the combined operation strategy is to simultaneously perform the operations that are combined at one workstation. In effect, two or more processing assembly, say, operations are being performed simultaneously on the same work path. In other words, say in a assembly line, if I've got number of bolts, simultaneously I do supporting at the same station at the same time, and this will reduce the cost of the machine, because the same part of the machine is going to do the work. And this is what we mean by simultaneous operation. Do simultaneous operations in the same station, and then move the product to the next station. Say in car assembly, say the tires in car assembly. You can bolt all the 4 tires in the car before moving to the next station, instead of having many stations for assembly of tires. Integration of operation. Another strategy is to link several workstations together into single mechanism using automated work handling devices to transfer paths between stations. In other words, integrate operations together so as all of those strategies reduce the size of machine and hence improve the productivity and reduce the cost. Increase flexibility. This strategy attempts to achieve maximum utilization of equipment for job shop and medium value situation by using the same equipment for the variety of parts or products. You have got an example like that when you have studied robotics, the clippers of the end effector of a robot. If you design the end effector of a robot to do multi-tasks, of course, you are going to reduce the number of equipment used in the machine, and this kind of utilization will reduce the cost of machine and at the same time improve production by not trying to change tools during the operation. Improve material handling and storage, and this is very important. A great opportunity for reducing non-productive time exists is the use of automated material handling and storage system. Definitely, if the machine waits for the material, that will take time. But if you have got a kind of, say, automated vehicle which move between the store and the machine, and this automated guided vehicle program to get the material to the machine as the time the machine needed, this of course will improve the production of the automatic line. Online inspection, and this one is very important. You have to have a kind of an inspection or measuring tools in the same machine, and this will reduce the defectives and improve quality. And as he said here, inspection for quality for work is traditionally performed after the process is completed. This means that the poor quality product has already been produced by the time it is inspected. And here actually he says that even if you find the product is defective from the various stages, you can remove it from the machine, and the machine or the machine by itself can remove it out of the machine and then proceed on the next product. And this of course will save the time which you are going to apply on completing the product. She's not going to pass the quality assurance measures. Process control and optimization. Manual control to automated control by optimization, we can give the best parameters since the individual's process can be reduced. Right? Plant operation control. Those which are not related to fabrication process. Each division specify automate business function and product design, and of course this the other things which will contribute to the production system. Computer integrated manufacturing, input from market delivery to the final customer. Every operation is integrated to the computer business function, product design, and so on. Actually, now those days we used to have what's so-called CIM, which is computer integrated manufacturing, where all the operations are computerized and controlled by the computer. Not the operation only, but also marketing and other business functions, all other business functions, sales, material purchasing, and so on. Right? Automated migration strategy. This is the third one. which is called automated migration strategy. Owing the competitive pressure in the marketplace, often need to introduce a new product in the shortest possible time. A typical automated strategy is shown. One of the big problems in automatic systems is that after you have the system, if I want to make changes in the product, that will cost me a lot. And in some cases, you can't do it unless you dismantle part of the system and have a new machines inside the system. Here in this, he said, owing the competitive pressure in the marketplace, of course, the competitors in the marketplace, and they always need a new and improved products. And they don't want the last product, even if the last product is functioning, but they want a new one, and which is better than the one they had before. Often needs to produce new products in the shortest possible time. And of course, this will make you or put pressure on you to have new products in a very short to manufacture new products in a very short time, or to develop new products in a very short time. A typical automated strategy is shown. Phase 1, manual production uses single station manned cells operating independently. And of course, this is not automation. It is just a manual production using single station manned cell operating independently. In other words, if the improvement is part of the product, just put a manual station inside the production line, this automatic production line, where those people do the improvements on the product and then push it to the next stage or push it to the store, right? Second phase is automated production using single station automated cell operation independently. In other words, I have a cell, one automated cell, which will do all the processes in the product independently. The phase 3 is automated integrated production using the multi-station automated system with serial operations and automated transfer of work units between stations. And this in this phase, you have got a multi-station, and each station will do a series of operations and then move to the next station, right? Some application of automated systems. Assembly lines. I talked about assembly lines, and you have got a complete story called automatic assembly. Automatic and flexible assembly systems. We are going to study flexible assembly systems in automatic assembly later. Material handling systems, usually with automated guided vehicle. Automatic storage system, where the store is operated automatically, and nowadays many companies use this automatic storage system where millions of parts kept in a store. Then if they want any part, the computer will send a vehicle, automatic guided vehicle, to get that part or that spare parts or something like that, right? FMS, Flexible Manufacturing System, and CIM, Computer Integrated Manufacturing Systems, also are some application of automation systems. Types of automation systems. Actually, I don't like this kind of trying to devise things to pass, but this slide is useful because if I got number of varieties and large number of quantities. If the varieties are low and quantities are high, I can use fixed automation, where the machine will do the job and do nothing but that job. And if I want to change anything in that machine, it's going to cost me a lot. If I've got medium varieties and medium quantity, I use flexible automation, where the machine got some parts which are fixed and can be removed from the machine, and other parts which can be moved and changed. Programmed automation, where the high flexibility, and this if the varieties are low, because uh, programming and changing tools will take time. So if I got a high varieties, low quantity, I'm going to go to program automation. If I got a medium quantity, a medium variety, I got flexible automation. And if I got large quantities of production and low varieties, I'm going to go to fixed automation. I think this is all what I want to say today. Thank you for your attention. Now, I want to give you a kind of assignment which I need you to do by yourself. And this assignment, very simple. Write some short notes about the following: definition of industrial automation, mathematical models for manufacturing, industrial system, control system, sensors and actuators, automated machines tools, industrial robotics, logic controllers, handling system, storage system, identification systems, manufacturing cells and assembly lines, and flexible manufacturing systems. I know this part C need you to go down the internet and the library and make a kind of research on it, right? If you have got any questions or you need any help, please contact me on my email address, which is m.i.shukri@gmail.com. Thank you for your attention, and I hope after coronavirus diminished, I can see you and we can talk face to face. Thank you very much. And this is actually my last lecture in this series of Corona lectures in Manufacturing Systems 1. Thank you very much.